Hello everyone. So today we'll be working on the IB Standard Level Maths Paper 1 for the May 2019 series for the time zone 2. Alright, question 1. This is a very straightforward probability question. I believe I've seen this question before on another paper with of course different numbers, but it's exactly the same. Now, the only thing you need to know is actually how to understand the table. And I actually think there's something wrong with the table, meaning the paper is set wrong. That shouldn't have been a big X. It should have been a lowercase x. This should have been a lowercase x. I think this is wrong from the for the paper. That should have been a small x, because what that means is, look, we have a random variable x, right? X is the general variable that we use, right? The x, yeah? And what they want to say is the probability that the random variable equals to small x is blah, 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 blah. So surely that all of these are small x's, yeah? So I think actually, yeah, I think the paper is actually wrong for writing a big X here. That should have been a small x, because what they want to say is the fact that probability of big X, our variable, equals to the first small x, which is 0, is 3 out of 13. Meaning, whatever you do, right? Let's say it's rolling a dice, a 4-sided dice, like a tetrahedron, but it doesn't matter, right? Like the probability that you get in 0 is that, and the probability that that variable is 1 out of 13. And the probability that the variable is 2 is 4 out of 13. And of course, the probability that the variable is 3 is k. So in that case, I actually think, yeah, there's something wrong with the paper. That's a mistake or a typo. That should have been small x, because all of these are small x. They really want to say that the probability that x equals to that small x is blah, 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 blah. But even if you, even if that's a mistake, it shouldn't stop you from doing the question. Part A, find the value of k. Well, since you know all these 4 outcomes, 0, 1, 2, and 3, would use up all of the probability, meaning they are, like, all of these events are mutually exhaustive, meaning they exhaust all the possible possibilities. That means you just add them all up and they will be 1. So you can just do 3 out of 13 plus 1 out of 13 plus 4 out of 13 plus k would equals to 1. Well, that means k is just 1 minus all of these. You think about the numerator, well, that's 8, so it's 5 out of 13. And that's it. Now, part B, find the expected value of x. You should know by now how to find expected value, right? The expected value is simply the probability of you getting a 0 and then multiply that by 0, plus the probability of you getting a 1, multiplied by, of course, 1, plus the probability of you getting a 2, multiplied by 2, plus the probability that you get a 3, multiplied by 3, and then it's quite straightforward. The first term, no matter what it is multiplied by 0, so it goes away, right? And then probability of x equals to 1 is 1 out of 13, multiplied by 1 is still the same thing, plus probability x equals to 2 is 4 out of 13, and then you multiply that by 2, and then plus probability equals to 3 is k, which is 5 out of 13 times 3. I should have times. And then therefore, that would just give you basically, that's 8, that's 15, and that's 1, so that's going to be 24 out of 13, and then you're done. You don't need to turn into a mixed number. That's good enough. Alright, question 2, a vector problem, but I think this is another very straightforward one. So they gave you 2 vectors, A and B. One is 0, 3, P, the other one is 0, 6, 18. Find the value of P so that they are parallel. By now you know, right? If A is parallel to B, then you know that A would just be a multiple of B, right? Yeah, it will be scalar multiple, right? Meaning they have the same direction. Well, then it's very straightforward, right? So you can just write 0, 3, P equals to K and then 0, 6, 18. That actually gives you three equations, right? 0 equals to K times 0, 3 equals to 6K, and P equals to 18K, right? So this gives you like a total of 3 equations because of the 3 components. And then K would equals to a half and therefore, of course, p would therefore be 18 times a half, which is 9. So that's it. All right. Now part B, if they're perpendicular. Then for perpendicular vectors, you would know, right? I mean, if two vectors are perpendicular, I mean, if A is perpendicular to B, then you should know, right? Then if you do the dot product of it, it would be 0. The reason why is because of this formula, right? Cosine theta would equals to A dot B over mod A mod B, right? That, right? I think I drew an extra line there. But the idea like behind this is the fact that, okay, look, if you have two vectors and you're trying to find the angle between them, you will get this thing, right? Then theta will be the angle between A and B. And therefore, if you think about it, right, if they're perpendicular, that means this is 90 degree and cosine 90 is 0, right? That means the dot product must have been 0. So that's the idea behind why if you dot two perpendicular vector together, they will give you 0, right? And then therefore just do it. So 0, 3p dot with 0, 6, 18. That would give me equals 0, and that will give me 0 plus 3 times 6. I mean, you might as well write it out, right? That plus 18p equals 0. Then you can get 18p equals to minus 18. So p is -1. So again, very straightforward. All right, question 3 is to do with functions. Then you have a look at the function, right? So they tell you that there is a function. Let me just write it out here, fx, which is 3x plus 1 over x minus 2, and of course x can't be 2. And to be honest, that already tell you the vertical asymptote, right? Actually, yeah, then part 1 is actually stupid because they already tell you that. So for the graph of f, right, write down the vertical asymptote. Now vertical asymptote simply means, okay, if I were to sketch this function, right, if I were to sketch it like say here, okay, so let's say I do not know what the function looks like. A vertical asymptote is simply a straight line, something like here, such that the line cannot cross. The function cannot cross this line, meaning the function cannot be evaluated at that value of x. Then of course, like they already tell you that, right? That's it. So it would just be x equals to 2. That is the line right here. Because, okay, look, the reason why, I mean, even if they didn't give you this, you should be able to see it. It's because if you, every time when you dealing with asymptote, always remember, you are going to look into like things you can't do in math. So for example, you can't divide by 0, you can't square root of negative, or unless you're doing imaginary numbers or complex numbers, or you cannot log 0, you cannot log a negative number, or for example, you cannot do tangent of 90 degrees. So these are the things you cannot do in maths. So right now you look at this, there's no sine or tangent or like logs, so there's no square roots as well. So the only thing you need to be careful that you can't do is divide by 0, because your unknown is actually, your variable is actually in the denominator. Then you can see that the denominator could equate to 0 when x is 2. We cannot let that to happen because you can't divide it by 0. Therefore, x equals to 2 would be a line that the graph cannot cross. All right. Now for the horizontal asymptote, it's a little bit hard to understand if you have not learned it, but if you do, actually that's very straightforward, right? You can see that it's just 3. But yeah, let's see. So horizontal asymptote means it's going to be an asymptote, let me use green, right? It's going to be an asymptote that's somewhere like here, for example. It's going to be an asymptote that like the y cannot be, meaning the function could not evaluate 2. Right? A vertical asymptote just now, like the 2, is where like that means the function cannot, right? Cannot be evaluated at x equals to 2, meaning you cannot put 2 into the function. But the other one down here, the horizontal asymptote, is where the function cannot be evaluated 2. It means something that the function could not give, right? Like the first one, when x is something, you're thinking in terms of the input, right? What can't you put in the function? But here it's like, what can't the function put out, right? Then if you think about it, right? Okay, look, for this function, I mean, since x could literally be anything, surely I could really get any number I can, right? If you think about it, if x is like literally anything, I can get any number by simply solving it equals to x, right? If you go from negative infinity all the way to positive infinity, surely x should go through so many different values that the function could pretty much output everything. Well, except one thing you can't do. Look, so this time we have to think in terms of x goes to infinity, because when x goes to infinity, what happens, right? Now remember, infinity is not a number, so you can't write x equals infinity. You can only write x approaching infinity, because infinity is just a concept, it's not a number. Right, when x is approaching infinity, what happened is fx is going to be very, very close to 3x over x only. Now the plus 1 and minus 2 doesn't really matter in that case because they are too small. Even though they're still there, the fact that they're still there makes that fx is only approaching at 3x minus x anyway. Like the plus 1 and negative 2 become more and more negligible as x get bigger. Imagine if x is like a billion, right? Then you have like 3 billion plus 1 and a billion minus 2. Then like the plus 1 and minus 2 doesn't really matter that much. And if you do x even bigger, then the plus 1 and minus 2 is pretty much negligible, even though they're still there. Therefore, the function is only approaching that value, but not exactly at the value. Then surely that already gives you a hint that what's going on, because look, then that means that's just approaching 3. The fact that it can't exactly be equals to 3 is the fact that these plus 1 and minus 2, even though they're negligible, they're still in play. So no matter how big x gets, it will only go ever closer and closer to 3, but not exactly 3 because the plus 1 and minus 2 are still there. Therefore, the value that it can't output is actually 3. Then it will be an equation of y equals to 3. It can't be exactly at 3 because the plus 1 and minus 2 make it so that it would go ever closer to 3 but not exactly hitting 3. Alright, and then for part B, now they gave you another function, which is x squared plus 4. Then they ask you to find f and then g of 1, right? So that really means what is the function here? That means a function of a function, which is a composite function, right? Then if you think about it, that would just equal to f of g of 1, like that, right? Then if you think about a g of 1, right? G of 1 is like x squared plus 4. So that would just be f and then 1 squared plus 4. That's what you get, yeah? And then that means it's 5, so you're doing f5, right? And then f, you already know is that thing, so let me just continue here. That will equal to 3 times 5 plus 1, and then 5 minus 2. And therefore, it would give you 16 out of 3. And of course, you can do it another way, which is actually figure out what is f of g first and then put the 1 in, which actually takes a little bit longer, but we can still do it. It's not that long. So the idea is that, look, for function fx means if I put an x here, the x would appear here and here. It's like just replacing these two by the x, right? Then what happened is, okay, look, if I put g instead, then g would just go to that place. So that would simply be 3, and then g is what? Like g is x squared plus 4, right? And then plus 1, and then g again, right? Which is x squared plus 4 minus 2, right? Like the idea is that if you put something into the f, that's right, that will goes into this place and that place. So if I put g, which we already know, which is x squared plus 4, into there, you would actually get the same thing. And of course, then you can put the 1 into the x to figure out the value, which would of course give us the same answer. Alright, question 4. It's a very straightforward function transformation problem. If you know your function transformation well, this should be literally not challenging at all. Well then, let's look at it, right? So part A, well, they tell you that's going to be a function here with the x-intercept of that and y-intercept of 8. So very straightforward. Now, they ask you to find the y-intercept of the graph of fx plus 3. Then you should know by now. Let's do A1 here. Alright, fx plus 3. This is a vertical translation up by 3 units. I mean, you can just justify by saying that, right? It's a vertical translation up by 3 units. Therefore, of course, the y-intercept would just go up by 3, right? The y-intercept equals to 8 plus 3 equals to 11. That's it, right? And then, of course, part A for II here. f of 4x here. If you know it, you would already know it does not change the y-intercept. It's a horizontal stretch with a scale factor of a quarter. I mean, you can also think of that in terms of a compression, because a stretch with a scale factor of a quarter is simply like squeezing it, really, right? But it's the same way. You can just write like this. And then if you think about it, right, if I simply just squeeze the graph, it shouldn't matter. Like the middle point here doesn't matter, right? It does not matter. So therefore, y-intercept does not change. Doesn't change. And therefore equals to just 8 again. Then that's it, right? You don't have to go through any like mathematical explanation. All you have to do, like just now, is just write the English to explain what that transformation is, right? Then part B, again, another transformation, the x-intercept of the graph of that. Now you already know on the top, right? You can write it like this, right? f2x, you can just write, that would be, again, a horizontal. I'm just going to do horizontal, again, a stretch with a scale factor of a half, meaning it actually squeezes it by half, right? Therefore, that means this number is going to shift all the way to the half, which is 2.5 here, right? Therefore, the x-intercept would equal to 5 divided by 2. Now, the better way to write it, okay, sure, is 5 times a half, which is 2.5, and then you're done, right? And then part C, describe the transformation by that. I hope you know by now, that is straightforward, right? That is a horizontal translation to the left by 1 unit, right? And that's really it. Now, for those of you who already know this, you can just skip ahead. But for those who have no idea what just happened, let me just go through like a little bit about function transformation in terms of how you should memorize it or how you should remember them. All right, so there are only ever 2 things to spot for. One is whether the transformation is inside the function or outside the function. That's the first thing you spot for. And if it's inside, it's going to be a horizontal. I'll explain all of this later, but let me just write that down. That will be horizontal, and outside would be a vertical transformation. And another thing is to spot for whether it's a plus or minus, or times or divide. If it's a plus or minus, it will always be a translation, meaning it's just moving. And then times or minus, it will be a stretch. Okay, and just last point to remember is horizontal ones, horizontal transformation are all sort of, well, opposite to your gut feeling. Okay, I'm just going to write it like this, your gut feeling. Remember this is quite easy to understand, right? Then we go through one by one, right? The first thing, okay, look, the plus 3 happens outside of the function, isn't it? If it's inside, it would have been f x plus 3 like that, right? So that would be inside, right? Then you can see the plus 3 happens outside of the function. So you know that is already a vertical, right? A vertical. And then it's a plus, right? So it's a translation, right? It's a translation. So we the first step, second step. And then, of course, vertical is just like how we think it is. If it's plus 3, move up by 3. You're done. Now, second part, then again, now the 4 here, let me use another color for this actually. The 4, let me use yellow. The 4 here, it's inside the function, isn't it? Inside. It's inside the function. If it's outside, the 4 would have gone to, well, if it's outside, it would be 4fx like that, right? This would be outside, right? That would be outside. If inside the function, then you know it's horizontal, so we know horizontal straight away. And then you think about it, it's a times. It's times 4, right? So it's a stretch. So the stretch is a times. But then, here's the thing. Remember, all horizontal ones are opposite to your gut feeling. Because if you think about it, right, if we times it by 4, surely we stretch it bigger by 4. But then remember, horizontal ones are opposite to your gut feeling. So it actually squeeze by 4. So the factor is actually 1/4, a quarter. Yeah, and then let's do another one. For this one, I'm going to use black. All right. So look, this again, actually it's the same, right? If it's 2x already inside, that's inside. If it's outside, it would be 2fx, right? And then same idea, so it's horizontal, it's times, right? It's the times, right? So we stretch, and then it works the other way, so it's a half. And then part C, I think I'm running out of color, but I'll try using a purple. So part C, right? So you can see the x plus 1, the plus 1 here, happened inside the function. That's inside. So you know it's horizontal, right? And it's a plus, so it's translation because it's a plus. And you would think, okay, plus 1, you move it to the right, right? But remember, horizontal ones go the opposite way, so it go to the left. And that's really it. All right, question 5. So they give you a function in terms of, x and k's for sure, where k is a constant. Then they ask you to find the value of k for which the function has 2 equal real roots. First thing you got to spot for here straight away, you have to know, right? It's the fact that, okay, fx is quadratic, right? Quadratic. This is, you have to spot this. Fx is quadratic. That's the first thing. And therefore, you're looking for the fact that, okay, if it's 2 equal real roots, 2 equal real roots, you should, this should be extremely alarming for you, right? Whenever you're dealing with a quadratic and you're looking for the number of solutions, you are looking to a discriminant. So discriminant equals b squared minus 4ac. You are looking into this. This is as straightforward as it could be. It has to be equal to 0. I mean, this is really textbook stuff. And just using these 2 points, you can do the whole question already, right? It's very straightforward. Then you simply actually do it, right? So b squared minus 4ac would actually be equal to b, which is, in terms of that, just 1, right? Just be 1 squared minus 4, and a is 1 minus k, and c is just k, that. And that would equal to 1 minus 4k plus 4k squared. Okay, then we need that to be equal to 0, right? So then we do another equation. So 4k squared minus 4k plus 1, I'm just rearranging this, will have to be 0, right? If you want, you can add another line here, right? It's b squared minus 4ac equals 0. But I mean, that's fine. We already set it here, right? So then you just solve it. Then here you solve another quadratic. And since it's the non-calculated question, either you can go for a quadratic formula or you can try to factorize it. I mean, if you're good with your numbers, I think you can already see that it is going to be this straight away. I mean, if you're not, it's okay. It's really okay. You can just use the quadratic formula, which is a minus b plus or minus b squared minus 4ac over 2a. You can use that to figure it out. It's completely fine. But if you can factorize it, sure, that's even faster. And actually realize it's a perfect square, right? So sure, then that means 2k minus 1 is 0, and therefore k is a half, and then you are done. Such an easy 6 mark, right? This should be very alarming, If you see a quadratic, they ask for the number of solution, you are doing your discriminant. All right, question 6, it's a log equation involving with 2 logs with a different base. Then I think straight away, you need to do the change of base formula. Now, I think this is given in the formula book. You can just go to that straight away. But the way I just memorize it is actually quite easy just to know it, right? Is the fact that if you want to change a base, meaning, okay, look, if I have a log and base a, it doesn't matter whatever base it is, right? And then of a, for example, right? If I want to change a base, meaning I want something that looks like this, right? Log another base, which I call it x, for example, of a, right? I want to change it to that. The way to do it is simply do this, right? Okay, what you do is okay, that would actually just equal to that over, it will also be that, but then you have the log using the new base of the old base. That's really it. That's how you go from base b. What you want is actually go from here to this part, right? That's what you want, to simply just change the base of the log. then that's how we do it. Then of course, it would be always easier to go from a bigger base than a smaller base. You'll see why, because we can avoid some fractions and this and that. So okay, look, you have, let me just copy down the thing. You have log base 4 of 2 minus x equals log base 16. And as I said, right, it's sort of always easier to go from the bigger base to the smaller base. So we're going to do exactly that. I want to change it to a log 4, base 4 of that, right? So that means I have to sort of compensate by dividing it with the same base of the old base, which is 16. So that's really it. I mean, if you don't understand and pause here and you think about what's going on, I simply just applied the formula there. And then the reason why I said you always want to change from a bigger base to a smaller base is because this number would always turns out to be, well, nicely, or usually an integer, right? It will not be a fraction. If you do the other way around, you get a fraction. But it's fine. If you do it the other way, it's also okay. I mean, so yeah, then you simply have log base 4 of 13 minus 4x. Now this you should know. If not, you can, oh yeah, you can't use your calculator. But then this you should know, right? If you are doing like log base 4 of 16, you are just really asking a question of 4 to the power of what equals to 16, right? Because like log the answer, like the 16, give you the power. You're taking the 4 to the power of what equals 16, then surely that's 2, yeah? So therefore that's just over 2. And this log base 4, 2 minus x. And you can move the 2 over. That becomes 2 log base 4, 2 minus x equals to log base 4, 13 minus 4x. Okay, at this point, you might be wondering what to do now, right? I mean, like, it's very tempting to just go unlog everything, but you can't exactly do that yet. You can only unlog things when you have log blah 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 equals to log blah blah blah. You can only take away the log if it's exactly in terms of that, and of course same base, right? Same base, right? If you have some integers here, like a 2 in that case, you can't unlog it. You have to move the 2 over to here as a power. That's your log rule, right? Before you can do it. So therefore, you actually get log base 4 of 2x, 2 minus x to the power of squared. You can only do that. And until this, we have finally figured out, okay, now we have log something, because we log something with the same base. Then very straightforwardly, this green would have to be the same as that part, right? And then therefore, you can, let me use green to continue. That would just be what? 2 minus x squared equals to 13 minus 4x. And I hope by now you can see that's going to be a quadratic, because you're going to expand this. It's going to 4 minus 4x plus x squared equals 13 minus 4x. Tidy everything up, you get x squared. Then nicely, the actually minus 4x got cancelled. So x squared simply equals to 9. Well, then that's not even a, well, it's still a quadratic at the end of the day, but it's an easy one because x is therefore just plus and minus 3. Now, please do not forget the minus. That's very, very important. A lot of students simply just go straight from, you know, x squared is 9 to 3. Remember, if you're doing a quadratic, please remember most of the time, it could have 2 solutions, all right? If you have the plus, remember you check for the minus as well, especially for squares like this. However, that's not the end of the question yet, because remember, we got this solution from a log, and whenever you're dealing with a log, you got to be very, like, alarming. Same with, like, square roots and, you know, like this and that. You cannot log 0, and you cannot log a negative number. Remember this? Just like how you can't divide by 0, or you cannot square root a negative, you have to remember you cannot log a negative number. Therefore, yes, I know we got x equals to plus 3 or minus 3. Well, actually, let me just erase the star. We got x plus 3 or minus 3. You have to be very careful. Okay, would any of these value give us a negative log somewhere in the expression? Because if it does, that means we have to reject them. All right? So you look at this, right? Oh, actually, straight away you see, right? 2 minus x. You can't do plus 3. Like 2 minus 3, if you do 2 minus 3, that's going to give you minus 1. And you cannot log in a negative number. That means actually the plus is the one that you got to reject. So you got to reject the positive, right? The positive, and therefore giving us only the solution of x equals to minus 3. So if you just forget the minus in the first place, that would be done. You will have no solution. So remember, there's a minus and a plus all the time. And then You're going to check whether you can do it. And then you check for -3, right? Turns out these are all -x, -x, -4x. So these are all fine. If it's all negatives, you will be logging a positive number, which is always okay. But you can see if x is 3, is +3, then you'll be logging some negatives, which is not okay. All right, question 7. So consider the graph of the function f equals to 2 sine x, sketching from the domain of 0 to 2 pi. Now they tell you that the graph f, this graph, intersect with the line y equals to -1 exactly twice, right? And then the a and b. So part A, they ask you for the coordinate of a and b. So how about we just label the graph a little bit more clearly, right? So since we know that this graph is 2 sine x, right? So I mean, like, a few things you need to know, right? Like normally, like the bound for sine x, like, yeah, is between 1 and -1, right? Now the fact that it's 2, that means like the peak now is 2 and the bottom like is -2. Even though this is not that useful for exactly this question, but these are the sort of insight that you need to see before you even start the question, right? And then sure, that's why like it will intersect the line at -1 twice, right? And part A, to be honest, is actually pretty straightforward, because you know if the line intersect, right? I think this by now has to be like automatic, right? Like if you know two lines intersect, you just equate the equation of the two lines. Meaning, if you know that like 2 sine x and -1 intersect, to find the intersection, you straight away just do 2 sine x equal -1. You just equate the two equations because you want them to have the same y values, right? Which is -1. So therefore, then a little bit of calculation gives you sine x equals to -1/2. All right, then the rest is quite easy, right? This is just your ASTC thing, right? So you actually just go straight away, draw that like cross here, and this is A, S, T, C, your 4 quadrant. And now, okay, look, this is a non-calculated question, so they will pretty much always give you really nice numbers. So 1/2, you should know, right? Sine what equals to 1/2, that you do know, right? That's like 30 degrees, right? Which is pi by 6. So normally, let me use blue actually. So normally, you're gonna have your that as pi by 6, right? That's your pi by 6. Let me just write clearly. That's pi by 6, right? And which is shown by this angle. Well, but this time we are looking for a -1/2, right? So you look for sign, right? ASTC. The place where it's actually negative would be given by these two red lines. So it's actually this solution and that solution. So it's actually in quadrant 3 and quadrant 4. And also that angle here would have to be pi by 6. And that angle here is pi by 6, which is like what? 30 degrees, right? So therefore, you would know what these two solutions are. Because remember, the way to actually get the angle is to count from the positive x-axis. It's always to count from here and then anti-clockwise to here. So this solution is actually, now you know this is like halfway, so this is like pi, which is 180. So this is just pi, and then add an extra pi by 6, which gives you actually 7 pi over 6. That's one of them. The other one, you know, like if you go full circle, now you start at 0, right? But if you go full circle, this is actually 2 pi, yeah? So therefore, you know this angle, like the actual angle, like the overall, let me use green, right? The overall, like you go from here all the way to here, this angle is going to be 2 pi and then minus pi by 6, which is going to give you 11 pi over 6. So therefore, you will know that these 2 points would be, you know, these 2 angles. It would be very like nice to see here actually, because you already know, okay, look, this is like halfway, right? That's going to be pi, right? That's going to be pi. So you should know like A and B should, you know, in 3rd and 4th quadrant anyway, right? Because that's actually, if I were to like sketch it out for now, right? Like the 1st quadrant, actually your A quadrant is here. And then S, and then T and C, right? And that's actually what your quadrant looks like, yeah? So therefore, you should know like A would therefore be 7 pi over 6, and B would therefore be 11 pi out of 6. So let me use green here. So if you do all the way to A, this number here, hold on, it's quite hard to draw. This is 7 pi over 6, and at b here, this here is 11 pi over 6. So that's how you would do your work. So part A is rather simple actually. You just solve your normal stuff. Now part B is actually harder, even though that's only 3 mark. But part B is actually a little bit more challenging. So consider now you have a graph of gx equals to 2 sine px, where p is bigger than 0. Now here's the thing, right? Like this is the function transformation we talked about before. If the p is a multiply, right? Like the function transformation is a p, right? And the p is inside the function, which is inside the sine x. And also, it's a multiply. Therefore, it's going to be a stretch and horizontal stretch. Then to realize whether it's an actual stretch or whether it's a compression is to do with like the value of p, whether p here, whether p is well between 0 and 1, or whether p is like bigger than 1, right? Like p is bigger than 1. If it's p is between 0 and 1, meaning it's like a fraction, like 1 of something, then it will be a stretch. If p is bigger than 1, then it will be a compression, right? So that's something that you have to know, like, you know, on top of your head, right? So this would be like a stretch, and that would be a compress. Yeah. Okay. So and then part B, right? So they were like, okay, find the greatest value of p such that the graph of g does not intersect with the line. Right, here's the thing. Now, this diagram is like quite messy, so I'm just gonna draw another one here. So far, you have got the normal 2 sine x graph, all right, and that's your axis, that's y, that's x, and this is -1, so minus y equals -1, and then you have your normal sine x, which is, or normal 2 sine x, which crosses it twice. Right, here's the thing. Now both graphs are sketched here. Both graphs are sketched between 0 and 2 pi. So if you really think about it, if it's not sketched between 0 and 2 pi, if the line goes on forever, for sure, like no matter whether it's px or whatever, it would always hit the line y equals to -1 because it has to go through a whole period. But the only way, if you think about it, right? Okay, look, if it's a compression, let's say we're trying to draw g, right? If I try to do a compression, it would look something like this. Something like that, for example, right? Well, and of course, it's going to hit like the -1 like quite a few times, because if you compress it, that just means it hit the period earlier, so it's going to hit the line, well, quite early, and it would definitely hit the line as well. The only way it wouldn't hit the line is actually if it's a stretch, because imagine it's stretched so long that, for example, it just goes to like this. Then you're done, right? By the way, remember that's 2 pi, right? Because we're only sketching between 0 to 2 pi. That means if you stretch the graph long enough, well, yes, eventually it will hit like the bottom part, like this 2 point. It will be somewhere like at this 2 point, right? It will hit it eventually. But since we're only sketching from 0 to 2 pi, if you actually stretch the graph longer, then very nice. We actually will not hit the line y equals to -1 before it hit 2 pi. So that's the idea we need to think about, right? So therefore, we know p is going to be a fraction between 0 to 1, right? It's going to be between 0 to 1. It's going to have to be a stretch, yeah? So then look at the question, right? Let me just erase this line. So the question is looking for what? They're looking for the maximum value of p. Well, this sort of makes sense because like if you think about it, right? If p is really close to 0, like let's say 1 out of like 100, like if p is that, then the graph is going to sketch the graph is going to get stretched 100 times. So of course it's going to work, right? Well, but like if p is like very close to 1, like right, let's say p is like somewhere like I don't know, 9 out of 10, then it's not stretched that much. And if it's not stretched that much, if it's only stretched by a little bit, maybe, like just maybe, it would actually hit the graph, like hit the graph here, sorry, hit the line before it goes through 2 pi. So of course it makes sense to ask what is the maximum value of p, just so you want to see like what is the limiting value. How big could p be before the stretch is not enough, right? So that means the optimal way for it to stretch is to look something like that. Now let me erase this line first, just to make it a little bit more clear. So the optimal way to stretch the graph is to do something like this, right? Imagine if the graph is stretched just enough so that like before 2 pi, it goes to that, right? Because I mean, we can continue like it would be that, right? Yeah, that would be the sign, like that would be g. Yeah. Imagine if like the graph is just sketched, you know, like just enough so that it hit like the line right after it passes 2 pi. Then we are good, right? So we need to look for this stretch, yeah? So therefore, what we're going to do is, how about we actually find what would the stretch be if I wanted to hit the first point at exactly 2 pi, right? Then that means I would want my g of at that point 2 pi. That means when I put in 2 pi, I want to hit exactly -1, right? This is what I want, right? Now that's g. How about I stretch it just enough so that if I put 2 pi in there, I hit exactly -1, right? Okay, then if we solve it, that will be 2 sine pi, well, that would be 2p pi equals to -1. But very nicely, we actually figure out what to do here, right? Because if it's a normal sine graph, it would hit at 7 pi out of 6, right? So that means we already work it out in part A. That means that has to be 7 pi over 6. So 2p pi has to be 7p over 6. Now a little bit of simplify, equals 7 out of 12, right? That means with the scale factor of p equals to 7 out of 12, the graph would stretch just enough so that it hits exactly -1 at 2 pi. Therefore, actually p is still not okay because like we want it to not intersect, right? Therefore, the answer will be p has to be smaller than 7 out of 12. Because only the case when p is smaller than 7 out of 12, then the stretch is big enough so that it won't hit before 2 pi. Because at p equals to 7 out of 12 would exactly hit 2 pi, right? And of course, if p is bigger than this, then surely it just doesn't stretch enough. If p is even bigger than 1, it's a compression, then it's even worse, right? So we need p to be smaller than its value. So that's how you do it. Now, another way to see this is to, actually plot it. Now, it's very nice to see it like here. So I plot the graph 2 sine px when p is just 1, which is just like your normal sine 2x graph, right? And then the purple line is 2 pi. So between the 0 to the purple line is the only region that we are considering about. Now, of course, now you can see like that would be point A and this would be point B, right? But now let's see if I start making p smaller, it starts stretching the graph. And if it starts stretching the graph, can you see, right? About somewhere like here, you can sort of see that the graph is going to start to stretch out so that it would not hit the point -1. It wouldn't hit -1 before 2 pi. So if I stretch even more, you can see that would definitely work, right? Because if you look at it, between the black line and the purple line, which is like 0 to 2 pi, the graph did not intersect the green line, right? It only intersect afterwards. So of course we are looking for the maximum value, right? Like, and we already know it's 7 out of 12, right? So we actually type 7 out of 12 for p. Then you can see exactly at 7 out of 12, it would hit exactly at this point. Therefore, if p is just anything smaller, the stretch would be big enough so that it won't hit before 2 pi. So that's how you would do your question. Question 8, a very nice box and whisker diagram. So they say a group of 10 girls recorded the number of hours they spend watching television during a particular week. And of course, you're going to have a distribution. So they say that the range of the data is 16, find the value of A. So, okay, look, this is so easy, right? The range is just the biggest minus the smallest. So that simply tells you A minus 8 equals to 16, right? So that would give you A simply equals to 24, right? I think that's very straightforward. Find the value of the interquartile range. Now, I think so far it's just textbook knowledge. So interquartile range is like that, right? That's already Q1, yeah? You have to know. And of course, 20 is your Q3. So therefore, it would just be 20 minus 15 equals to 5, right? If you really want to be, rigorous about it, that actually, technically, let me just draw it here. Technically, this is your Q0, like where you start. That's Q1. That's Q2, which is a median, and Q3, Q3, and that's Q4, which is the 100th percentile, right? Now, part C, the groups of girls watched a total of 180 hours of television. find the mean number of hours that the girl in this group spent watching the TV this week. Again, textbook knowledge. So yeah, 180 hours between 10 girls. So it's simply just 180 out of 10 equals to 18 hours. Right? Now, and then going on, you can see there's a little bit more because now we introduce a group of 20 boys who also record the numbers, and then the result is that. So that X bar tells you the mean, right? That's the mean equals 21. Well, that technically sort of tells you that, like, pretty much on average, each boy watch more television than the girls. However, the standard deviation is 3, which means actually the spread is like quite big, but we'll see, right? So find the total number of hours the group of boys spend watching the television that week. Now, if you know that the mean is well, let me just write it here. Well, since the mean X bar, I can write mu as well, right? Is 21. Therefore, like total is simply just equals to 21 multiplied by how many boys? 20, right? That, and therefore that will give you 420 hours. Yeah, so that will be it. And then find the mean number of hours that all 30 boys and girls spend watching television that week. I really don't know why this is 5 mark. This is supposed to be, this is so easy. So, all right, let me actually do DII here. No, that's DI, right? DI. Let me do, actually I'll do it here, right? Here. So, you know the total amount of hours spent by the boys is 420, and total amount by the girls is 180, so you just add them together. That would be the total amount watched by both all the boys and all the girls. Then simply divide by the number of boys and girls, which is how many boys are there. So 20, right? And then there are 10 girls, so divide by 30. That should nicely add to 600 and divide by 30, which is be 20 hours. So I have no idea why this is 5 mark. It's so easy, just 2 steps. And then part E. Now, the following week, the group of boys had exams, all right? So during the exam week, the boys spent half as much time watching the television compared to the previous week. Now, for the exam week, find the mean number of hours. Now, here's to do with the sort of like what we call the data transformation, right? It's like, okay, you have a bunch of data, but imagine if every single data point inside the bunch of data got halved. Right? Then what happened to like the overall things like mean or standard deviation or things like that, right? So let me do EI here because EI is actually quite simple. If you think about it, it makes a lot of sense, right? So imagine originally every boys spent 21 hours a day to watch TV on average, right? Now imagine everyone suddenly spent half the time. Well, then surely the mean got halved as well. I mean, it only makes sense, right? I think that makes a lot of sense, right? So, or you can do a bunch of different ways. You can actually just go straight away and tell like therefore new mean is simply just 21 divided by 2, which is 10.5 hours. If you can try to justify it by thinking about this, right? Because if everyone spent half the time watching, that means in total, before, like total time spent equals to 420 hours, right? If everyone spent half of the time watching, new total is simply just 210 hours, right? And then following from that, you can do 210, simply divide by the number of boys, which is like 20. Then you should also get 10.5. But it should only, like, this makes a lot of sense if you really think about it. And if you think about it, it also works for things like median or mode, right? Because if every number got halved, or for example, to be honest, for mean, median, mode, they would transform exactly as how the data transform, right? Imagine if everyone spent 2 more hours watching it, right? Or suddenly spend 3 less hours watching it. It doesn't matter because like the mean, median, mode will simply transform like how the data transform because like they are in a way sort of part of the data, right? Now EII, let me just actually do it here. EII here, like the second part. Let me give myself a little bit of space. Now this might not be that obvious, however. because they're asking for how the variance changes. Now, if you know, this is actually quite straightforward. You know, it's simply if everyone spent half the time watching, you multiply by the variance by a quarter instead. But now let's see what that means, right? So variance is something what we call the measure of dispersion, right? Measure of dispersion, meaning they're looking for how spread out the data are, right? In short, variance, now I'm just going to give you a very brief introduction of variance. If you have a data variable x, variance x is simply doing this, right? Imagine you have a spread of now this might not be a normal distribution, right? I'm just trying to sketch it out. Now, because the way I draw it, that looks like a normal distribution, but that might not be, okay? Like, what variance means is simply asking, okay, I have a bunch of data points, right? Like here, along here, yeah? And then, how far away is it from the mean, right? How far is each of them away from the mean, okay? So basically, how spread out each data point is, right? So, okay, first thing first, if the whole bunch of data, x simply like plus 10, that is not going to change the variance. Because if everyone shifted by 10, surely the spread is the same. Because you simply take this graph here, you just shift it to another side. Like, yeah, sure, the mean changes, right? You can see the mean, like the middle line is the mean, right? The mean changes, right? Mean changes, mean new. But the thing is, like, the spread is still the same. It's still the same width. So if you plus or minus, it doesn't change the variance. Well, however, if you multiply it by a number, it does change it. Because if you think about it, variance is looking at the distance between the points, right? Then if you think about it, imagine you're in a test, right? If you are, say, 10 points behind one of your friends, then if everyone's point suddenly got doubled, now you're actually 20 points behind your friends, right? If everyone, like, score suddenly, like, got cut in half, then also your distance between, like, each of the data points also got cut in half. Therefore, it would change according to that. However, just a quick thing about variance is that variance is actually the distance squared, right? I hope you remember, variance is actually standard deviation squared. Standard deviation is the average distance between the points to the mean. Variance is actually the distance squared between the points and the mean, all right? It's like basically a sum of all of these distances, but squared, right? But squared. Therefore, if you cut every point in half, right? If every point was cut in half, well, the distance got cut in half, but the variance is distance squared. Therefore, it actually got cut in a quarter because a half squared equals to a quarter. Now, I'm trying to, like, very briefly run through this whole idea, even though it should take a little bit more time. But again, we are only focusing on the solution here. So, so basically, new variance. The answer was something like this, right? So, new variance was simply equals to old variance x times a quarter. Well, times a quarter. Therefore, it's just originally it was the standard deviation is 3. Giving you the variance 9, right? Because 3 squared is 9. So it's 9 times a quarter, which is 9/4. That will be the answer. All right? Okay, question 9. Let theta to be the obtuse angle such that sine theta is 3/5. Find the value of tangent theta. Right. Actually, this is a rather tricky question. There are a few ways to go about this. The easiest way I could think of is actually, when you see sine theta equals to 3/5, I hope that should ring a bell in your head. It's the triangle 3, 4, 5. Now we will deal with the obtuse later. All right, we'll deal with the obtuse later. So that means I think if you see, like, yes, 3/5, or if it's 4/5, it should be very clear to you that it's going to be the Pythagorean triple, right? Meaning that is the hypotenuse is 5. Assume that's theta. Right, and then that will be 3, and that will be 4. It's a 3, 4, 5 triangle. I hope by now you have to know, right? 3, 4, 5 makes a very nice right angle triangle. So does things like 6, 8, 10, or 5, 12, 13. These are the very famous Pythagorean triple, meaning they work for the Pythagoras theorem. Also means they work with the right angle triangle. Right. So I hope you can see that straight away. It's 3, 4, and 5. And therefore, if you think about it, if that's sine theta, then tangent theta, using the same triangle, is simply opposite over adjacent, so which is 3/4. Well, but you're not done yet. Because the idea, well, the reason why I tell you, like, you have to think about the obtuse angle, right? Is the fact that, yeah, like, you have to think in terms of ASTC, right? ASTC. So yeah, because you might be wondering, right, I've drawn theta here, but of course, if they say theta is obtuse, surely that's not right. Well, indeed, that is not right, but the value is still right. The value is still right, except you have to think about the sign. Now, that theta here that I've shown is actually the solution to do with this. But when they say theta is obtuse, actually, the one that they meant is, let me use green here. The one that they meant is actually this one, where there's also theta, but they're actually looking for this angle. Right? That means you actually know theta belongs to quadrant 2, right? Theta belongs to quadrant 2, which is the sine quadrant. Then in that case, you should know that tangent at this quadrant should be negative. Therefore, that would give you tangent theta to be negative 3/4 instead. So that would be a way you can think about it. Yeah. Now, another way you can do it is completely mathematical, which is also okay, but it will require you to do the same ASTC argument as well. So you can, even if you cannot spot the Pythagorean triangle, right, the right angle triangle and stuff like that, you can do something like this, right? If sine theta is 3/5, now you should also know that there's another identity of sine squared theta plus cosine squared theta is just 1, right? Then using this, you can actually work out what is cosine theta, right? Because then cosine theta, I'm going to skip a bit of steps, right? It's just going to be square root of 1 minus sine squared theta, right? It's just rearranging from this. If you're unsure, you can pause and you're trying to rearrange it, make cosine a subject. Therefore, that would just be square root of 1 minus 9/25, which is 16/25. Again, I'm skipping a bit of steps here, and that would give me plus or minus. Well, actually, it gives you plus or minus here, right? Because there could really be plus or minus. Well, of course, because of ASTC, right? And also when you undo a square. So therefore, there will be plus or minus 4/5. Then you think about it, right? It's in the second quadrant. Therefore, cosine should be negative, right? Therefore, actually, since theta belongs to the second quadrant, you would actually get cosine theta equals to minus 4/5 instead. And therefore, the last thing you do is simply do tangent theta equal to sine theta over cosine theta. So that will simply give you 3/5 over minus 4/5, which also give you minus 3/4. Now, I skipped a little bit of step here, but if you're unsure, you can pause it, try to do it yourself, but that could be another way you need to do it. But if you can spot the triangle, like the Pythagorean triangle here, this right angle triangle 3, 4, 5, remember, this is a very nice one. It will be a lot easier. Now, part B. Line L passes through the origin and has a gradient of tangent theta. Find the equation of L. Then if it passes through the origin, surely by now you would know that it would just be y equals to mx. No, c, because the y-intercept is 0, right? Like the y-intercept equals to 0. Because like if it goes through like the origin, the y-intercept is exactly 0, right? Then with the slope of tan theta, we've got tan theta already, right? Which is minus 3/4. So therefore, we just got that, and then x, and then we're done. That is the equation of L, all right? Now, part C, they actually give you another function. Let the function f, given here, equals to ex sin x, blah, 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 like basically the random function for now. Find the derivative of f. Well, sure. I mean, that's actually textbook, isn't it? Like, just differentiation. Now, since we're running out of space, I will have to zoom out a little bit and do it here. So let me do part C here. So you can write fx equals to that, which is ex sine x minus 3x/4. Then you're looking for derivative. So the first part here, it has to do it by product rule, meaning keep one of them constant, differentiate the other, which is cosine x, and then plus keep the other one constant, differentiate the first. But if you differentiate e to the power of x, it just gives you the same thing. So it gives you this. And minus 3/4x, which is just 3/4. And that's it. Oh, I just realized it did the whole thing in one step. All right, I don't know why this is 5 mark, but I guess maybe you have to write some steps with it. But if you do it differentiation like enough, you should get the answer straight away. It's actually very simple. But I mean, if it's like 5 mark, maybe add a few more steps in the middle, something like this maybe. Let me just select these parts and then move it down. All right. And maybe look, if it's like you're in an exam, I mean, like surely you don't need to, right? But you do something like this, you show you're doing product rule, right? So you're gonna do like f dash x here, that's going to be something like ex, and then you actually show you're doing product rule, right? So ddx of sine x, and then plus, well, this time you do sine x, you keep this one constant, and then ddx of e to the power of x, and then minus, well, I guess you explicitly show that you, I don't know, I don't really know, like, I don't know how this is 5 mark. Like, this is like, literally, it took me like 2 seconds. But sure, that's how you do it, and then you show it. All right, part D. All right, part D. So now they actually tell you that the following diagram, let me zoom back in here. The following diagram shows the graph of f, the f from 0 to 3. Line M is a tangent to the f at point P. Given that M is parallel to L, find the x coordinate of P. So yeah, I mean, in the first glance, you might not know how to start, right? Yeah, but how about we write out all the clues that we're given? If we are given that M is parallel to L, at least we can write the equation of M as y equals to minus 3 out of 4 x and plus a constant, right? At least we can write it like this, right? Because we know what it looks. We know the slope of the line L from above, right? Like this one right here. Yeah, that's L. If they have the same slope, so surely you do that, right? Because they're parallel. And then the next clue is the fact that they told you explicitly, they gave you 5 marks for it, right? To differentiate the graph. So surely we're going to do that. And also, you see the word tangent to graphs or like normal to graphs. So surely you know you're going to do something with the direct differential that you've just found, right? So let's say P here is P and Q. It doesn't matter. I can call it X and Y, P and Q. It doesn't matter for now, right? So what happened here is that, let me zoom out a little bit. Let me zoom out a little bit here. The clue that you were given is that like the gradients at point P is that, let me just write it down. The clue that you're given is that the gradients of the curve, we are looking at the curve actually, of F at P, at the point P, is this, minus 3 out of 4. Then I hope you know, right? If you work with the differential, if you differentiate the function, that exactly gives you the gradient function, right? So therefore, you actually will be, therefore f dash, right? That means if you differentiate it, and then when you put in P, right, at point P, would actually equals to minus 3 out of 4. This would actually be how you're going to solve the whole equation. Now let me recap a little bit how I think about it, because like the way you do it, once I tell you the answer, I think like it's quite easy to work out the math. But the way I think about it is like this, right? So okay, if I do not know how to start, how about I write down every single clue that I was given? I'm given this, right? So I wrote this down, and then I also like look for keywords like things like tangent. I also like keep on track of like what I've been doing throughout the whole question, because throughout the whole question, last part they gave me 5 marks to find the derivative, right? And if I see I need to find a tangent of a curve, this is a curve, isn't it? A tangent to the curve, and I found the differential, like the derivative of it, like of the function. Surely I know I'm gonna be like doing like the gradient thing, right? Like even, yeah, because this question could ask in another way. They could instead actually give you point P and ask you for the gradient of the tangent, or the normal for that matter. If it's for the normal, then you just have to do the other one with the m1 times m2 equals to minus 1, right? But of course, like now they're doing tangent only, so that's fine. So yeah, like this is how I think about it, right? I write down all the clues. I look at sort of any keywords that sort of give away of, you know, what I need to do, and then I simply basically go with the logic, and that is the logic behind my whole like math, right? It's the idea that means the gradient of the function f, the curve f, at the point P is negative 3 out of 4. Therefore, I can write that, meaning I've just now, okay, I'm gonna continue here. Like just now I've worked this out already, right? That tells me that at this point P, e to the power of p cosine x will be cosine p plus e to the power of p sine p minus 3 out of 4 equals to 3 out of 4, right? That means like this is the gradient, right? Because this just now is a gradient. Now at point P, we put in the x value of P, right? Because we assume P is like PQ. And then if you think about it, okay, look, it might not be easy to figure out what's going on here, but I hope you can see if you think about it, right, like that and that is the same, isn't it? So that tells you that EP cosine P plus EP sine P has to be 0, right? It has to be 0. So that means, now I don't want to use up the space for the next question, so I am going to continue here. Okay, right. Let me just take this part. Let me just take this part to here. Okay, we're going to continue there because I don't want to take up the space. All right, so let me zoom back in here. So we are solving this. Well, but how do you solve it, you might ask, right? There are a few ways you can do it. Either you can factorize it, EP, and then cosine P plus sine P equals 0. And then, now since EP can't be 0, right? E to the, like, no matter what number you have, like 2 to the power of anything, it can't give you 0, right? So that tells you that cosine P plus sine P has to be 0. Now, the way to solve these type of questions, the first time you do it, it's really hard. Like, it's very hard to think about what to do. But this type of question comes in very often, and you should be able to like spot the thing. So next time when you see it, you should know how to do it. Like this type of question is when you have a cosine and a sine like this, or it could be like 3 cosine. It doesn't matter. The point is, like, you can't do much about it, right? Because it's not a square. If it's a square, you can use this identity here. You can go from sine to cosine and maybe get a quadratic. If it's none of those here, it's just a cosine P and a sine P. So remember this, the way to do it is to do something like that. So sine P, therefore, equals to minus cosine P, simply like that. The next thing you do is to divide cosine P. So you get sine P over cosine P equals to minus 1. And because that is actually tangent P equals to minus 1. Now remember this, like, it might be very surprising to actually see a tangent out of sine and cosine, like out of nowhere. But remember, this is the way to solve this type of equation, like these type of equation. The first time you encounter this will be hard because it's actually quite hard to spot that you can divide cosine P like that. But once you know it, next time when you see this type of question, it should be straightforward. Well then, it's very easy, right? Because once you got that part done, you simply need to find P. Now, -1. Now you should know, right? Like tangent 45 is 1, right? But then you have to know we are looking at -1, right? So again, you do ASTC. That tells you that it's going to be in quadrant 2 again. So that tells you it's going to be actually 135 degrees. But remember, the reason why I do degree is just because it's easier to remember. But remember, whenever you're dealing with calculus, or also basically, if you look at this, right? If you look at the graph, that here, the x here, is not in degrees, right? Not in degree. So you can't give your answer as a degree. I mean, to be honest, every time pretty much if you do calculus with your cosine and sine with angles, it will pretty much always be in radian. All right, especially in this case, like the graph, if they actually give you a graph, right? If you do your coordinate geometry, as long as the x-axis is not in degree, then this will always have to be given in radian, or else it's actually just wrong, right? So therefore, that have to be 3 pi over 4. Yeah, or else it would just be wrong because x is not 135, isn't it? If you think about it, right? The p here, like if this is not 135, that is not 135. That is 3 pi over 4. Right? Because you may be wondering, sure, like I know this is like okay, this 135, like pi over like 3 pi by 4, that's okay. But what about like the rest of the solutions, right? Like there's one here as well, right? It wouldn't work because that number would actually be bigger than 3. So you're looking for a number between 0 and 3, so therefore only this one would work. Only this one is actually between 0 and 3. Okay. All right. Question 10. So they gave you a function and they simply ask you to differentiate it. So very textbook work here. But I think some of you might actually be wondering how to do chain rule, because I do think a lot of school teaches chain rule rather like, well, confusingly, I'll say that. Because I think the chain rule that you see is something like this, right? dy dx, and then that will be like dy df, and then df dx, something like that. That's the chain rule that you learn. Well, I mean, it's quite hard to understand what it means, like if you have no idea like how everything's working anyway. So the way I remember chain rule is a bit easier. Is imagine this, right? Like the reason why you can't differentiate it is because like there's something inside, yeah? So how about what I'm gonna do is, how about imagine just pretend that this is an x. I'm just gonna draw a box over it. If you pretend that that's your x, then that's very straightforward, right? Then that's why, like, well, then dy dx, then it would simply be, if that's your x, right, then you get like 3 out of 2. And then, of course, the green box, which is your x, I guess your x, right? Your x. And then, of course, the power drops at 1 and a half, right? So this is no problem, right? Like, it's the idea that if you first differentiate, x to the power of 3 out of 2, what you get is you first, the power drops down, and then the power got -1, so which is like a half. So that's the same idea, right? Like, yeah, like in the ideal world, surely that is so good because we can just treat that thing as an x, so then we can do it. Well, but of course, we can't. Right? I mean, like, you can't just do that. So what we do to use this nice trick is that we have to do some compensation. We have to compensate by differentiating whatever that you have just treated as your x, right? I think that's only fair, right? Because or else, like, differentiation will be so easy. You can just treat anything as your x and differentiate it like that, right? So that means if I do that as an example, you know y is that thing, right? So I'm just going to get 3 out of 2, and of course bracket x cubed plus x to the power of a half. That is basically treating, because you actually know what's going on inside the green bracket, is your x3 plus x, right? Like that. So imagine if we just treat that as just 1x, right? Then just differentiate it as if it's just an x. But then, of course, we got to compensate. Again, like, remember, like, life is not that nice, so you have to do compensation. You have to compensate by differentiating whatever you have just treated as your x, which is that thing. And therefore, you would just get 3 out of 2, and then bracket that thing, and then multiply by your compensation, which is, if you differentiate this, it's quite easy actually. It's just 3x squared plus 1, right? So that would be the answer, okay? So remember, this is how you do chain rule, is that if for some reason it will be easier if you can treat something as simply an x, right? Now, let me like go all the way to somewhere like here to show you another example, right? That's the previous question. Now, another example I can give you is, for example, imagine this, right? If I ask you to differentiate, let's say, sine of x squared plus 2. Let's say 2x, right? Right, what do you do? Now, wouldn't it be nice, wouldn't it be nice if that thing is simply an x, right? It would be nice if that's simply an x, right? So what I'm going to do is, straight away, I pretend that that is actually an x. So if that's the case, I'll get cosine x, yeah? I'll get cosine of that, right? I pretend that's for my x, right? So I'll just get cosine of that. But then, of course, you have to do some compensation. You have to multiply by whatever that you have just treated as your x. Now, you've just treated x squared plus 2x as your x, right? So therefore, you multiply by compensating that thing. And then therefore, your answer is just cosine of that thing. Multiply by, that's 2x plus 2, right? And that's your answer, right? Now, to better write it, you usually write it in front of it. So that, and then cosine of that, right? That's how you do it. So remember, the way to do it is pretend that something is just an x and differentiate it, and then simply compensate by using this trick, right? You got to compensate by differentiating whatever that you have just pretend to be your x. That's it, all right? So let me go back to here. So part B, right? Now that's part A, so I'll put A here. Part B, hence find blah, blah, blah. So they want us to integrate that thing here. And I hope you can see that the function they ask us to integrate is extremely similar to the function with like the answer we had in part A. And also you see the word hence. If you see the word hence, that means you're going to use something from before. Right, I think that's very straightforward, right? Now, in that case, it would be nicer to actually see, the answer from part A could be written as something like this, right? 3 out of 2, and then 3x squared. Now, I'm just going to write it in the right order, so we have the same thing, right? 3x squared plus 1, and then to the power of a half, I hope you can see that means square root, right? You have to know that. Then you can see, wait, this is exactly the same thing except that's a 3 out of 2. So what we can do is, how about this? Now imagine this, right? If there is indeed a 3 out of 2 here, like that, then the answer is exactly y. Because if y differentiate into this, if you integrate it back, surely you get back to y, right? But the thing is, you don't actually get a 3 out of 2. So what we are going to do is, how about we actually force a 3 out of 2 there? What I mean by that is, let me just copy this thing down. You'll see what I mean. I'm just going to copy this for now. So what are we going to do here is that we are just going to force a 3 out of 2 into the integral, like here. Well, but of course, we can't simply multiply by 3 out of 2, right? To make it so that we are not actually, making the number different, we have to, again, multiply this by 2 out of 3. Then if you think about it, right? Now, remember, the constant could actually go in and out of the integral. It doesn't matter. Then if you think about it, like that and that would actually cancel out to be a 1, right? Like 2 out of 3 times 3 out of 2, that gives you 1. So at the end of the day, I did not change the value of the integral, right? By multiplying by 3 out of 2 and then I multiply by 2 out of 3 in the front, I just multiply by 1. It's like the idea that if I have an x, right, I can do plus 1 and then right after I do minus 1. Then I didn't change the value, right? I just do plus 1 minus 1. So it's the same thing here, right? I gave it like a 3 out of 2, but then straight after I gave it a 2 out of 3 as well. So I didn't change the value. But then you can see that that's very nicely, the 2 out of 3 stays. And this part, like the whole part here, is very nicely just y, which is x to the power 3 plus x and 3 out of 2. Now again, remember, right? Because just now we differentiated y here, we differentiated y into that thing. So if we integrate that thing, it gives me back y. So that's the idea. And of course, a little bit more, because you're integrating, make sure you have the plus c. But that would be it, right? That's very straightforward. The only trick you need to understand is the way how you force the 3 out of 2 by also making a 2 out of 3, so that it cancels out. You didn't change the value of the number. It's just like plus 1 minus 1 or like times 2 divide 2, right? It doesn't change it. Now part C, I'm going to zoom in here. So part C. Now again, consider now you have a function of that's your f. Let me actually write it out. So that is x cubed plus x, and then the whole thing square root. And you have gx, which is that function. I'm going to write it as well. So that is 6 minus 3x squared, and then a bunch of these, right? So, okay, by now, I hope you can see sort of like some similarities between f and g and the things that we've worked before. Because surely there's literally no way they give you like 2 random functions out of nowhere, right? I hope you can see like that is, well, okay, similar to the one we have in B. Because both of them would have that same thing here, right? That and that, yeah? So, yeah, let me just write it better, like that, right? So, maybe, just maybe, we can use something from above later on, right? That's something you have to keep in mind. Like, as you go through the question, keep in your mind that what have you been doing and this and that, right? Now, and then the shaded region R is enclosed by that, and that, so sure, that's fine. Now, part C, write down an expression for the area of R. Right, then actually that should be no problem, right? Because what that does is simply just integrating, right? The bound is from 0 to 1, right? From 0 to 1, yeah, from 0 to 1. And then it's the function g, like that's g, right? Let me just write that as g, right? And that's f. It's just g minus f. It's just the difference between g and f, right? Like that's g, that's f. So you're gonna do that, and then g is well, I'm just writing g minus f and dx. That's, well, that. Of course, we have to substitute the value of g and f in there, but this is the idea. Now let me zoom out a little bit because we are really running out of space. I'll do it at the page below, right? So then if I continue here, that'll just be 1, 0, and let's see what's g. G is 6 minus 3x squared, and then that thing minus f. So minus f is simply just that, right? That would sort of give you the mark already, but for our own convenience, it'd be nice if we actually factorize it, right? Because we know that thing could be factorized. So what I'm gonna get is this 6 minus, and then that could be factorized, right? Let me just show you what I mean. That thing, this expression here, could be factorized. So I'm gonna write that x thing first, and then I start a bracket, is 3x squared. Now it's a minus here, so if I had started the bracket, that would have been a plus 1, like that, right? Because that is like a 1 here, right? Yeah, because it's a minus, if I group into the bracket, it has to be a plus. Because if you think about it, right, if you expand the bracket like that, that becomes a minus anyway. So it has to be that, right? And then, of course, dx. And that would be your answer. And also, isn't this, you know, somehow quite nice to like what we had just now? Because isn't this blue part exactly the same as the one we have in part B, right? So you can see, right, we are going to use that eventually. All right, then sure. Now let's do part D. Now, let me just do part D here. Let me use black. So hence, find the exact value of R. So we are going to do that, and then 6 minus that. Now, for the sake of it, like we in part B already found it, right? So let me just write it exactly like that form. So 3x squared plus 1, and then that, and then we do dx, right? So just so you know, for integration, for the clarity of, you know, for the purpose, we can do something like this. If it's like 6 minus that, you can actually chunk them into 2 separate integral, right? You can chunk them into 2 separate integral. That's completely fine. And then just like differentiation, right? If you differentiate that, you're differentiating 1 by 1 anyway. So if you integrate that, you are also just integrating 1 by 1. So that's what you get. And well, very nicely, right? You can see that this part here, you can just refer to part B, right? Because you actually got it right above here. So that means this is just, well, 6x, right? You integrate it, give you 6x, 1, 0, minus that part there, you got it here, right? You don't need the plus c if this is a definite integral, meaning if you have a bound, you don't need plus c anymore. So it's just 2 out of 3, x 3 plus x 3 out of 2, and then 1 and 0 like that. And then the rest is actually quite straightforward, because that you simply get 6 times 1 minus 6 times 0 minus, for the, well, to make ourselves easier, I love to use square brackets, because square brackets really separate the whole thing to make it very sure that that is a chunk. You see what I mean? 2 out of 3, and then that will be 1 cubed plus 1, and then 3 out of 2, and then minus 2 out of 3, 0 cubed plus 0, 3 out of 2. Yeah, you can exactly see like the square bracket means like this whole thing is a chunk, right? And of course that would be 6 minus that, I'll keep a square bracket, right? It's 2 out of 3. 1 cube is 1 plus 1 is 2 times 2 and 3 out of 2 minus, that's all zeros, right? Zeros. So then I think we're almost done. Then therefore, again, 6 minus 2 out of 3. Now 2, like what is that thing, right? 2 to the power of 3 is 8, and then 8 to the power of half is just square root 8, right? Just that. But then of course, square root 8 could be written as 2 root 2, right? So it's 6 minus 4 over 3 root 2. And that's the answer, right? I mean, for those who are wondering why that's 2 root 2, or that is a 2 to the power of 3 of 2, it's the same thing as 2 to the power of 3, and then square root, which is like root 8, right? And that is just 2 root 2, right? Okay, so that is my answer.